This conference will now be recorded.
iPhone waste. అది చెప్పు ఈ అడ్డదిడ్డలకు పడినా మహైత ఒక 2,000-3,000తో పాటు నీకు ఇష్టం పోయి అంటే 15,000 20,000 పట్టుకొని మనకు నా డిస్ప్లే ఏంటండి తప్ప కంఫర్ట్.
Wait, sir. After 2 minutes, we can start.
Okay, sir. Okay.
Vijaykanth, sir.
Sir, told me so.
Hello.
Yes, sir. You are audible now.
Vijaykanth, sir.
Sir.
Hello.
Hello.
Sir, your voice is not audible.
My voice is not audible. My voice.
Audible, Vijaykanth. Audible. You are audible.
It is. Okay. From my side, there is no problem, sir. Sir, please check your side.
Yeah, Vijaykanth, sir, your voice is audible.
Okay, sir. Okay. Thank you, sir.
Audible.
Now it's audible. Hello. Vijaykanth,
Okay,
sir.
sir. Okay, sir.
Now it's audible, sir.
Okay, okay.
Is Satyesh ma'am is there?
Savtesh ma'am.
Wait for ma'am.
ఆఫ్ చేసానులే కెమెరా. నన్ను బలి చేయడానికి వచ్చారా మీరు? Sir.
Wait,
Yes, sir.
wait a minute, sir. Wait a minute.
Okay, okay, okay. I'll
Let's people join the people participants.
Shall we start? Rajkumar
Gautam
sir.
sir.
Gautam sir.
Shall we start?
Yeah, I think we should start now.
Yes, sir. Thank you, sir.
Okay, thank you, sir.
Sandesh
Thank
madam
you.
is there?
Amai.
Ma'am.
Okay, so start. Okay, you continue.
Okay. Okay.
Yes.
Okay, let us start our section. A very good morning to everyone. Welcome to day 3 of 3-day FDP on innovation opportunities in emerging electronics and communication technologies, conducted by Department of ECE, DVR and Dr. H.S. Mick College of Technology, Kanjigicherla. Today, we have a renowned scholar, Dr. Ajay Yadav from Bennett University as a resource person. Now, I am inviting Mr. Rajkumar Jaishwal, one of the program coordinators, to present a MIC Odyssey.
Is the backbone of social development. Technical institutions are the temples of learning that marshal in the development. The year 2002 marks the birth of Devineni Venkatramana and Dr. Himshi Government College of Technology, President Kanchichalla, now an integral part of CRDA. An eminent engineer and entrepreneur with distinction of bagging awards, educationist and visionary founder, Dr. N.V. Ramana Rao has been shaping the destiny of the college with the sole mission of achieving symbiosis between institute and industry. May provide technical education from the level to teaching. As of today, 4,000 plus students are on rolls. During the past 1.5 decades of excellence in providing quality higher education, foraying into diversified disciplines of learning, the College of Technology has steadily evolved into an institute recognized for the experiential learning it offers, the competent and compassionate faculty, academic vibrancy, and infrastructural facilities. It is branded as one of the leading colleges in Andhra Pradesh for its quality-conscious approach, awarded with the most prestigious accreditation of NBA for 4 BTech branches from AICTE, NAC A from UGC, and ISO certification. A notable feature of a quality education institute is the one that provides holistic engineering education, catering to the needs of the industry, aiming at the overall development of a student. Nick organizes many events. One such event is Agama, a national level student technical paper contest, an annual event being organized since 2008. Another milestone event in the academic calendar is Working Models Exhibition, where students prepare various engineering models and exhibit them for the general public and school students. The innovative abilities of mixed students are harnessed to the health. Students get access to the knowledge of various technologies through departmental chapters. For students to be employable in this highly competitive environment, students are trying to hone
ఇదమ్మా బాత్రూమ్ తీసుకొచ్చి లోపల బాత్రూమ్ ఈ పక్కనే
identifying the demands of the current industry and preparing students towards the
ఇది ఎందుకు ఈ గుద్దలు దిగుతున్నాం
in-house trainers and external agencies,
మనం కూర్చొని టీ తాగాలంటే సిలిండర్ని కూడా మోల్కి పెట్టుకోవచ్చు.
also collaborates with APSSDC and TEP of ISB Hyderabad in this regard. Everyone is born with innate enthusiasm and latent talents. It is the responsibility of the educational institutions to provide the right platform to the talents. To hold such talent, which has a platform called ICE. Various competitions are conducted and important national and international days are celebrated as part of ICE. Make students bag innumerable prizes every year in various events in and outside the campus. Mansana in Kuprosand is a Latin phrase, usually translated as a sound mind and a sound body. Living in this ancient heritage, sports are made the pivotal point of Greek educational policy, and this reflects in the provision of spacious playgrounds for playing cricket, football, and volleyball, besides indoor games. Development of a nation and its value system should go hand in hand. To inculcate individual social responsibility in the students and make them fully human and fully alive, and this is wing of MIC conducts various activities for extending a helping hand to the orphans and offering help to the needy during natural and man-made calamities. Another feather in MIC's studded cap is its fully automated digital library. MIC Library is a treasure house of knowledge with about 50,000 volumes of books, innumerable international journals, hundreds of e-learning materials by reputed institutes of higher learning, PDP facility and AC reading room are the unique features of MIC Library, which provides academically rich ambience for carrying out scholastic pursuits. MIC has a hallmark of its excellent and conditioned transport system that connects the college with Vijayawada and other parts of CRDA. It blends the excellence in extracurricular activities with excellence in curricular and co-curricular aspects. At the annual day celebrations, the students organize FET, where they put up various streams through a process of competitive bidding. The FET helps them to nurture their managerial and marketing skills. The day-long FET culminates in a kaleidoscopic cultural fiesta, besides honoring the academic achievers with gold medals. Towards the addition to the mix profile is the formation of CRDC, the research wing of the college. The CRDC provides guidance on research, including processing of research proposals to various funding agencies like DST, AICTE, and UGC. Since its inception in 2002, it was riding on the wave of success with a self-conscious agenda of quality in every step of its growth. It is the same parameter of quality-conscious engineering education that helped make receive NBA accreditation for all the eligible BTech branches, CSC, CE, EEE, and Mechanical in one go. It has also received NAC A certification from UGC. Believes in the philosophy, there are promises to keep and miles to go before I sleep. Many things have been achieved in this policy, and many have to be achieved. Under the sagacious vision of the chap, and the leadership of Christ and Director Planning and Development, able stewardship of CPU and Optical, we should go stronger by scaling later fees and crossing new stars in achieving common status.
Thank you so much, sir. Now I invite
Thank you, sir.
Mr. Tirupati Rao, sir, Assistant Professor, Department of ECE, to introduce today's resource person.
Thank you, Vijay. Good morning, everyone. And we are very happy to see this much strength on the third day too. Myself, I am Tirupati Rao Kommu, Assistant Professor in the Department of ECE in DVR and Dr. H.S. Smith College of Technology. And I'm very fortunate to present the biodata of today's speaker, Dr. Ajay Yadav, on the topic Wide Innovation Opportunities in Wireless Optical Communication. Dr. Ajay has earned his PG from IIT Dhanbad, or also called as ISM Dhanbad, in 2013, and PhD from IIT Delhi in 2018. And to speak few of his achievements, Dr. Ajay has qualified both GATE and UGC NET, and he is the recipient of National Photonic Fellowship. And coming to Dr. Ajay's teaching experience, Dr. Ajay has worked as an assistant professor in Gaut Women Engineering College, Ajmer, Rajasthan, and currently he is serving as the assistant professor in Bennett University, Greater Noida in Uttar Pradesh. And he is also the reviewer for some of the journals, reputed journals, that is Optics Express in OSA and Photonic Network Communication in Springer, Applied Optics in OSA, and so on. Dr. Ajay has received has delivered many expert talks in various reputed engineering colleges, and a participant in national and international workshops and seminars. Under his belt, Dr. Ajay has published his research work in many reputed journals and conferences. With this, I would like to conclude the biodata of our today's resource person, Dr. Ajay Yadav. Now, Dr. Ajay Yadav Garu will deliver his expert lecture on innovation opportunities in wireless optical communication. Thank you for the organizers for the opportunity given.
Thank you, sir. Thank you so much. Now I take the privilege to invite Dr. Ajay Yadav to take up the section.
Okay, thank you for the organizers to invite me for this talk. And today's topic is wireless optical communication. So this topic was like part of my PhD research also. And initially, I will give a brief introduction about the domain of wireless optical communication, and then I will take towards the research side, so that if anybody who is interested in doing PhD or who is already doing PhD in this domain, he can find some useful resources from my talk also. So wireless optical communication is basically, if you see communication system, then we have a transmitter, receiver, and in between transmitter and receiver, we have atmosphere. Okay. So in case of wireless optical communication, we transmit optical signal which carry information in the free space, or basically in atmosphere or in the confined environment. Okay, so basically optical signal is used for transmitting information from the transmitter to the receiver in case you have wireless optical communication. So definitely if you are using optical signal, then definitely at the transmitter also you have some optical source, and at the receiver also you have a optical detector. So this is basically your wireless optical communication, where information is transmitted from the transmitter to the receiver by the help of optical signal, and you have optical source and optical detector at the means optical source at the transmitter and optical detector at the receiver. Now, basically, if I talk about wireless optical communication, then it works in the same IR range in which your optical fiber systems work. Okay, so basically, if you see our optical fiber systems, then you will find that we have different optical windows, and generally, basically, we use 1550 nanometer optical window for communication in the optical fiber network. So that communication window we can use in the optical wireless optical communication system also. We can use the same thing. Okay. Now, if we see the commercial application of this, then it can offer capacities in the range of 100 Mbps to 2.5 Gbps, and there means demonstrations means where we have seen that data rate can go as high as 160 Gbps. So these are the capabilities, and it can be used for commercial as well as in the lab also. People have some lot of amount of research. Now, why we want to go for wireless optical communication? The first reason is unlicensed spectrum. If you see our RF communication, now people means the various companies like Airtel or Geo, they offer licensing fee to the government. Okay, but in case of wireless optical communication, there is no requirement of that license. Okay. Second is the bandwidth requirement. If you see nowadays, we have means online classes of the BTech students, and we are now in a webinar. So, and even the school education nowadays, it is online. So for tackling this large bandwidth requirement, we need a technology which can work or which can offer large bandwidth. So it has a large bandwidth as compared to your RF systems. Okay, because your RF systems, they work basically in the maybe hundreds of megahertz. But if I talk about wireless optical communication, then it works in the range of hundreds of terahertz. So definitely we have large bandwidth here. The third is your less power requirement. Okay, so as compared to your RF, the power requirement is less here, because this wireless optical communication, it is a line of sight technology. So you have a fixed transmitter, receiver, and in the direct line of sight means there won't be any means power is not spreading just like in the isotropic manner, just as your RF communication. So that's why we are able to save a lot of power. So there is less power requirement is less in this case. Now, the next is your less EMI, because the frequency of communication here, that is hundreds of terahertz, and the EMI, electromagnetic interference, is less at this high frequency. So EMI is less due to, because if you see most of the sources which are generating noise in the RF communication, they won't be able to affect the performance of this system, wireless optical communication system, at such a high frequency. Okay, definitely noise will be there, but that won't be that much, that noise. Now, fifth is your high security. Now, in this case, we have a line of sight technology, we have a transmitter, and we require a matching receiver, and this optical or we can say that light cannot penetrate. Okay, if I take the example of Wi-Fi, in Wi-Fi what happens? If you have a Wi-Fi, then Wi-Fi, it can be suppose that I have the rail Wi-Fi, okay, that we are using nowadays. It is free of cost also in many railway platforms. So this rail Wi-Fi, it can be hacked by any hacker easily, because it has a more rich, and it can be hacked and somebody can access your profile and all these things can be done. But when you are using inside the room a Li-Fi system, or you can say the wireless optical communication system, which is directed only on your laptop or your PC or your smartphone or tab, then you will not face that. Okay, so that's why it is highly secure as compared to your that system. Next is your low cost of deployment. If you see the antenna size, then the antenna size in this case is very small, and this transceiver, it can be deployed inside the room. Why I'm saying low cost? If you see, suppose that I'm taking the example of your fiber to the home, okay, FTH. Now for that we require installation of fibers, means and we need fiber to till our home, so that we can have a large bandwidth communication. So that thing is basically not here. So for that means because it is wireless communication, so deployment cost is very low. I can take the example, suppose that if there is any catastrophe or any problem, then in that case, like if there is any earthquake or something like that, so deployment of these transmitter, receiver and all these things is much easier as compared, and low cost as compared to your RF communication system, as well as your other mode of deployment. So it has low cost of deployment. Now for every technology there are advantages and disadvantages, so there are disadvantages here also. So first disadvantage is that because it is line of sight technology and we are using light, so in the light it can be attenuated by the atmosphere. So in this attenuation, basically it is in the form of absorption and scattering of optical signal. Okay, I will go in detail later on. Now the second thing is you're blocking by the buildings and objects or personnel, because it is line of sight technology. How we blocking? Suppose that if you have a transmitter receiver, then in between, if there is any person who comes, or if there is any bird or any building which comes, then communication will not take place. So because this is the limitation of this. Now you have fading.
Your mic is off. Thank you, sir.
So now there is a fading of signal also. What do you mean by fading of signal? Variation in the strength of the signal at the receiver due to atmospheric turbulence or scintillation. Okay, if you see for RF communication or wireless communication, we see there is multipath fading. So here the fading will take place due to atmospheric turbulence. Now what is atmospheric turbulence? How it is taking place? That I will explain later on. Now, the third factor is background noise, because if you see, if in RF communication we have noise in the terms of thermal noise or different type of noise, flicker noise is there, so many noises are there. Here, the noise is basically due to sun, lamps or tube light, because there are two type of wireless optical communication. One is indoor, that is used inside the room or hall or office. Outdoor means outside, maybe in between the two buildings. So in those kind of scenarios, there will be background noise due to the sun, because sun is also a source of light. Okay, and the other sources of light are what? Tube light, it can be a LED, it can be a laser diode. So these are all optical sources. So if there are these kind of sources in the vicinity of the transceiver, then definitely they will act like a background noise source. Now the terrestrial links means the link between two buildings. Okay, the communication link between two buildings. So these are these are limited by few kilometers, means we can't it is not like that I have a transmitter at one building and I am transmitting this information up to hundreds of kilometers. No, it is not possible, because in this case, if you have terrestrial link between two buildings which are I can take example of 1 kilometer apart, then the laser which we are using, we cannot increase the power of the laser because we have some eye safety considerations. Okay, we cannot increase the power of laser to a large extent, because due to we have some eye safety considerations. To do that, there are some limitations. So we can say that you can use this terrestrial link for few kilometers. It can't be used like your RF communication for means 50, more than 10 or 20 kilometers. So we can't use this. Now, if I classify the wireless optical communication system, then I can classify basically in two parts. One is your indoor system, another is your outdoor system. Indoor system means inside the room, hall, or office where we have a transceiver, like, and outdoor means we have a system which is in between two buildings, or means outside, means not inside any campus or something. Okay. Now, in the indoor system also we have classified in three parts. One is your directed beam, another is your non-directed beam, and third is your cellular. Now, what is directed beam? Which means that there is a direct communication link between transmitter and receiver, like we can use a laser at the transmitter and a photo detector at the receiver. Okay. Non-directed means what? That we have it means the at the source we are using LED or LED as a source at the source side, and at the receiver side we have photo detector. So it is having wide divergence angle as compared to a laser. Okay. The third is your cellular system. Cellular system or diffuse system also we can say that. Suppose that you have one room. In that room, you,
Sir, please unmute your mic.
so in the cellular system, you have a means Li-Fi router or Li-Fi, you can say that in your room, and you have installed that at the top of the ceiling or on your roof, and the so optical signals are coming in all directions, and you have different gadgets like laptop or PC or smartphone or tab, and the signal will go only in means in that direction only where you have these gadgets. Okay, so these are the example of indoor. Now you can have your outdoor system also. Now, in case of your outdoor systems, there are two type of links. One is your terrestrial, another is your space or laser links. Terrestrial links means, as I told you, in between two buildings, it is only few kilometers, like 1, 2, 3, 4, maximum 5 or 6 kilometers. Okay. In case of your space or laser links, the distance between the transmitter and receiver is in hundreds, from thousands of kilometers to millions of kilometers. Now, so here it is classified in three parts. One is your interorbital link, it between different orbits. That is, the distance here is from 10,000 to 15,000 kilometer. Now the second is your inter-satellite link. It means that the distance between the transmitter and receiver is 30 to 40,000 kilometer here. Now third one is your deep space link. That is millions of, like from Earth to different Mars, or you can say that. So that can, or from a one satellite to Mars. It means it means in between two planets. Okay. So here the thing which should come in our mind is that at one side I am saying that in case of terrestrial kilometer you have distance limitation, like we can't use this means up to a 4 or 5 kilometer. Beyond that we cannot use this system, WO system. But on the other hand, in case of space links, I am saying that we have distance of 10,000, 15,000 kilometer or 30 or millions of kilometer. Even there we can use it. So why we can use it? The question which comes in our mind. So the reason is that in case of space, we don't have uh, attenuation in the form of absorption and scattering. We don't have atmospheric turbulence. So because if you have a communication system, then there are certain things which are affecting the performance of the system, or which are not allowing the signal to travel to a longer distance. So those things like attenuation or atmospheric turbulence, if it is not there, then we can transmit our signal up to millions of kilometers. So that is the reason behind this. Now I'm taking the example of indoor system. So if I talk about indoor systems, then Professor Harold Haas, he coined the term Li-Fi at his 2011 TED Global Talk. He is a German professor of mobile communications at the University of Edinburgh, UK, and he said first about this thing that okay, there can be a communication by the help of light. Okay, so that's why he coined the term Li-Fi there. And if you see Philips also, they have a transceiver which can be used for communication. Okay. Now the question which comes in mind is, what is Li-Fi? So Li-Fi is a cellular wireless networking that is using light. So this is the difference. We are using light here, not our RF frequency. And so in case of Wi-Fi, we use RF frequency. So here in this case, we are using lights. This is basically a cellular wireless networking. In this case, we use LEDs basically, and these are used as visible light transmitters. And if we say, means in the future lighting system, now we use lighting systems only for what, illumination. Like we want to see something, we want to read a book, or we want to do something within the, we want to see what is there. So we use lights or LEDs nowadays, because LED is more power efficient. So we use LEDs nowadays. But in the future, you will find that you will use the light not only for illumination, you will use for internet also. Okay, so that will be the future, and that you will see in the 5G. Okay, in case of 5G, you will see that thing. Now, if I say about the visible spectrum, then it is an untapped resource and it has a large bandwidth. So I mean, the researchers, they are trying to use this untapped resource. So there are more possibilities here that we can use it. Now the Li-Fi offers many scope of applications. It can be used in areas like bank, large enterprises, aviation, or defense, because it can be used in our 5G, or because if you have 5G, then there you will require more bandwidth. So that can be taken care of by Li-Fi. If I see the market growth, then it is projected that means there was a compound annual growth of around 82% from 2013 to 2018. So it has a lot of scope. Li-Fi has a lot of scope. And if I show you that how it works, then you can see here that we have Li-Fi technology. It means that you have one server here, then you have streaming content, it is connected with the internet. Now at your home, at your premises, you have a power button. When you switch on this power button, then this lamp, it will be on. This power button will be on. Then there is a driver circuit which is driving these LEDs, different LEDs. Okay, so means by the help of this, what we have these LEDs which will glow and data will be transmitted. These are acting like a transmitter here. Okay, these are acting like a transmitter. Now you can means at the receiver side you have photo detector. Okay, this photo detector, it can be with your, it is a Li-Fi dongle, and it can be with your laptop, tab, or a smartphone. Now if you see the inside view of this, you have a photo detector. And what is the purpose of photo detector? It converts the optical signal into electrical signal. Okay, then what we are doing, we are doing the amplification and processing of the signal, and this signal is received at means a receiver. Means you can recover your signal after that by means if you are using any modulation technique or any error correcting technique, then you can utilize that also. That is part of this. Now if I say the real world applications, then Philips Light offers 2x2 luminaire with data speed of 30 Mbps, which is sufficient for high quality media files. So right now we have 30 Mbps data speed. Now in the government of India also, they have set up education and research network for setting up Li-Fi test board for indoor and outdoor applications. So our government of India, it has also an eye on this, because if we want to catch up in the for 5G, then we need this technology. So that's why what they did, they partnered Philips Lighting and IIT Madras to carry out 3-year planned R&D project from 2017 to 2019. So now the project, I think, is over. So whatever be the results, means people are focusing on this Li-Fi and indoor and outdoor, because if you want to have a good 5G, then we need this basically. Now there are various applications of this. We have means, or we can say that though where you means where applications are large bandwidth applications. We the place means the instance where you need large bandwidth, like video on demand, virtual reality, robotic surgery. So there this technology can help a lot. So the Philips Lighting, they say that they achieved this 60 Mbps data rate at the end of 2019, and at Oxford University, some researchers they have shown data rate up to 254 Gbps for this case. That is only inside the lab. So, but there are certain limitations also. What are the limitations? One is the standardization by the IEEE, like those standards which are like IEEE 15.7, these are outdated, and they do not define many aspects of Wi-Fi. So we need a complete standardization now, and it's not available in standard devices even today. Now, if you see initial investment in this case, so it is higher than a regular Wi-Fi network. But in future, you will find that the Apple devices, they will come with Wi-Fi technology. Now I will show one video. I think then you will know that how things are taking place. This is from Pure Wi-Fi, and that is the company of Professor Harold Haas. So then you will be knowing that what is happening here, and things will be much clearer to you that how indoor wireless optical communication system works. So I am showing one video.
Imagine a world where light becomes data. Wi-Fi is simple but powerful. We all know how a light bulb works. When an electrical current is applied to an LED light bulb, a constant stream of light is emitted from the bulb. Which we see as illumination. Since LED bulbs are electronic devices, the current and therefore the light can be modulated at extremely high speeds. This can be detected by a photodetector and converted back to electrical current, therefore carrying data. This is the nervous system of an internet revolution. Wi-Fi doesn't replace your internet service provider. You'll still need them to get the internet to your home or office via wires. However, once you have that high-speed connection, you can deploy your fast, secure Wi-Fi network using power over Ethernet or power line communications. Wi-Fi offers greater density than many other radio frequency solutions. For example, if you have an average Wi-Fi router in your office that provides up to 100 megabits per second and 15 people are connected to that router, it means that you might only be able to access 4 megabits per second. However, with a Wi-Fi network of lights that offer 42 megabits per light, even if you had only 8 lights in your room, those same 15 people could share more than 300 megabits per second. That's dense and fast wireless communication. Real Wi-Fi is also bidirectional, full duplex, and high speed. Data is transmitted and received at the same time, resulting in a really fast, reliable user experience, especially when doing things like Skype calls, video streaming, and virtual reality. Real Wi-Fi is fully networked. That means all the lights in your Wi-Fi network can speak to each other and hand over as you move around the space. Each light even has its own IP address, which means that you can offer location tracking and geofencing within your network. Wi-Fi, a world with unprecedented data and bandwidth. Be part of the light revolution.
So that's it. This is about indoor systems, and I think all of you have listened to, or you can search this video on YouTube also. You will find there also, or you can search this video on maybe on the Pure Wi-Fi website also. I got from there on. So if I say about that means that was only the Wi-Fi, it was for indoor system. But when you have outdoor system, then we want communication between two satellites. It can be the communication between satellite to a means Earth remote station, or it can be a communication between two aeroplanes, or from between two means there can be many scenarios you can see here that we need this wireless optical communication in the why we need this for outdoor systems or outdoor basically. So these are the different scenarios which I have shown you here in this figure. Now if I say about the technical reality, that what are the reasons that why people they have not used, means what are the factors which affect the performance of this wireless optical communication system, then the first factor is your beam divergence. Because as I told you, we use basically optical source. This optical source, it can be a laser, it can be a LED, okay, or light emitting diode. So when you use a laser or LED, then we use optical lens, okay. So this there will be means due to this beam divergence, there will be spreading of the signal and power density. Okay, so as a result of that, what will happen? The performance will be affected. The second factor is atmospheric channel losses. That is basically in the form of your basically attenuation and in the form of absorption and scattering. The third factor is your atmospheric turbulence. So this turbulence, it affects the performance by degrading the performance, or signal strength will vary due to this atmospheric turbulence. The fourth is your background noise. Now, what is beam divergence? So there is a diffraction of the optical beam around the aperture at the end of telescope. What is telescope here? Means we have lens, okay, which is used with the optical sources, and because if you are using a lens that at the end of the aperture, or we can say that the edges of the lens, we have optical the beam, it will spread due to diffraction. Okay, if you see in this example, I have shown you that how the beam is spreading. Okay, so due to this, what is happening? If you have a receiver here, then the signal strength, or you can say that the power density, it will be less here due to the spreading. So as a result of that, the performance, or you can say that means when power will be less received, then your SNR will be less, and SNR will be less, then the probability of error will be more. Okay, so this is basically in terms of totally in the terms of probability of error. So means power density is reduced. Now there are means sources which have a low divergence angle. So if you have a terrestrial link or link between two buildings, then definitely we want the optical source to have low divergence angle, low spreading. But if you want to use the same source for indoor, then we want it to have wide divergence angle, so that it can be used for means so that it can communicate with all the devices inside the room or hall. Okay, so it depends that on your application, whether you want to use the optical source for the outdoor or indoor. If you want to use for outdoor, then you want to that it should have low divergence angle. Low divergence angle means what? It should have low spreading. But if you want to use that inside the room, then we want to it to have wide divergence angle. Wide divergence angle means what? It should have more spreading of the signal. Okay, so generally if we see that the divergence angle is 1 to 2 milliradian for terrestrial wireless optical communication, that we generally use. Okay, the second factor is your atmospheric channel. Okay, as I told you earlier also that there is absorption and scattering in the atmosphere, and as a result of that, the signal strength is or signal is attenuated. Okay, so what is absorption? If I say in general way, then basically when the energy of the incident optical beam photons is transformed into other form of internal energy, that can be heat, lattice vibration of the absorbing particles. Now what are these absorbing particles who are absorbing? It can be rain, fog, it can be dust particles. So the basically they means the, because when you transmit say optical signal, it means that is light, and light consists of what? Photons. So what happens, the energy of the photons, it get transformed into other form of energy. Okay, it can be the heat or lattice vibration of the absorbing particles. And what are these particles? It can be a fog, it can be rain, it can be a dust particle. Okay, the third factor means then the next thing is your scattering. Scattering, you see in terms of your means clouds also we have scattering, different type of scattering. So means in the during the sunrise and sunset, we see that the color changes, that is also due to scattering. Okay, the color during morning and evening, and that orange kind of color or yellow color end of color, it is due to scattering one. So what is scattering? Basically it is redistribution or redirection of light. Okay, so due to this, what is happening? The light is spreading. When light is spreading, then we have a reduction in power density. So this absorption and scattering, it is modeled by Beer-Lombard's law. Okay, if you want to have a mathematical model of this, then there is one law that is used, basically that is your Beer-Lombard's law, and by the help of this law we model these two, or you can say that attenuation in the atmosphere by the help of this law. So because if we are doing research, then you need to have a mathematical model of this. So we are using Beer-Lombard's law for that. So now attenuation is done by various weather conditions. Okay, and so the first is, as I told you, first is your fog. The fog, it basically has due to fog, what is happening? Absorption is happening, scattering and reflection. Okay, so and if you see about wireless optical communication, then the impact of fog is highest as compared to your rain or dust particles and all other Okay, the impact of fog is highest, and it can attenuate your signal as high as 350 dB per kilometer. Okay, then the rain, it has less impact than fog. So attenuation due to heavy rain is around 10 dB per kilometer. So you can see that how much difference. With rain, you have only attenuation of 10 dB per kilometer, but with your this fog, you have very high attenuation of 350 dB per kilometer. Okay. So the third factor is your snow. So in the snow, you have attenuation in between fog and rain. Okay. Then your dust particles, they scatter the optical beam and reduce the power density. So the dust particles are there. So these are the various weather conditions which affect the performance of the wireless optical communication system. So when we are doing the mathematical modeling, then we take into consideration all these factors. Okay, that how much fog is there in the atmosphere, is there any rain or not? If rain is there, then we need to take care of that. If there is snow or dust particles, then we take care of that also. Now, if I say about atmospheric turbulence, then what is atmospheric turbulence? So if you see in the atmosphere, we have eddies, which are basically air pockets of different size in the atmosphere. And these eddies, they get due to temperature and pressure variation in the atmosphere, they get mixed up. And as a result of that, we have variation in the refractive index of the atmosphere. Okay, so atmospheric turbulence takes place due to the random motion of these eddies. Okay, due to this random motion and due to mixing of larger eddy with smaller eddy, what is happening? Refractive index of the atmosphere changes, and as a result of that, when the refractive index changes, then the optical signal which is getting transmitted from the transmitter to the receiver through this changing refractive index, it will also get affected. As a result, the signal strength at the receiver varies, and this is basically what? This is your fading of the signal. Okay, as a result of, and the atmospheric turbulence, it is basically characterized by the refractive index structure constant Cn square. Okay, so this is your. Now optical beam propagating through atmosphere, basically, or turbulent atmosphere, it is basically affected by three effects. One is your beam wander, second is your scintillation, and third is your beam spreading. So these are the three methods. It depends on the size of the AD and the size of your transmitter aperture lens. Okay, depending on that, we have these three. If the size is more, then you of the AD is more than the transmitter aperture, then beam wander. If size is equivalent of your transmitter beam aperture, transmitter aperture and the AD, then it is scintillation, and if it is less, then it is beam spreading. So based on that, we are classifying these effects into three types. Okay, when we do the mathematical modeling, then generally we take into consideration the scintillation effect only. Now if I say about the background noise, then I told you earlier also that there are natural light sources like sun, moon, and other celestial bodies which induce noise at the photodetector. Okay, and there can be natural light, not natural light sources like our tube light or LED or laser diode. These also basically act as a noise in addition to your, if you have a optical signal, then these also act like a noise sources. So the background noise sources here we have classified into two types: localized and extended sources. So localized are what? Which are pointed in a particular direction. So if you see your atmosphere, then in the atmosphere you have due to scattering in the atmosphere, we have light, the ambient light which is in the atmosphere. This is also a noise. So this is basically your extended source. Localized point sources are what? Like tube light, LED, which are basically direct in which are direct which are in the line of sight of your optical receiver. So these are basically localized point sources. Okay, now for indoor wireless optical communication, we have fluorescent light, sunlight. So these are also again the noise sources which are basically there, and they affect the performance by inducing noise in the receiver. Now I am taking towards the a research topic, that is basically optical CDMA, which I did during my PhD research at IIT Delhi. Okay, so what is optical CDMA? Optical CDMA is a multiple access and multiplexing technique, and it has various applications. Basically, we use it in optical fiber network as well as we can use it in the wireless optical communication also. So initially, I used it in the optical fiber network. There I designed a new two-dimensional code. I evaluated the performance of that in the optical fiber network, then I took the same code in the optical wireless optical net communication also. So there I use the code, and so if you see here, I have given in this figure, I have shown you OCDMA PON architecture, that is passive optical network. Okay, so we have optical line turner. So information from the user, that is in the form of bits, it is encoded by the encoder. And if I talk about OCDMA, then I have some code sequences, okay, at the transmitter. So these code sequences, suppose that you are transmitting your information in the form of 1 and zeros. So this 1, it is assigned a code sequence. This 0, it is assigned a code sequence depending on the encoder technique which you are using. Okay, suppose that I am using OK modulation. So in the OK modulation or intensity modulation, what we do, if there is one information bit at the means from the user, then this one is assigned a sequence. Okay, if you have 0, then 0 is not assigned a sequence by the encoder. So in this manner, user 1, information from the user 1, it is assigned a code sequence. Now this code sequence assigned signal, it is basically transmitted from the transmitter, and you have a coupler. Okay, the coupler is like your means simple coupler, which so in the same manner you can have multiple users. The signal, optical signal from all the users, which is basically coded here, it is basically by the received by the coupler, and then you have channel. This is optical fiber here. At the receiver side, you have a splitter, that is power splitter. It is basically split the signal, and at the decoder you have the same sequence which you have at encoder 1. At decoder 1 you have the same sequence which you have at the encoder 1. This information, it will be recovered here by using the same code, by using a basically your correlation basically. Okay, so we do the correlation operation here at the decoder, and in this manner we can recover our data or information bit which was transmitted from the, if I say about the data, we have data recovery circuit here. So the signal up to this extent is optical. Now here we will have a photo detector which will convert this optical signal into electrical signal. Then we have a threshold detector which will detect whether it is 1 or 0. So in this manner we can recover our optical signal from the transmitter when you are using optical CDMA. Okay, now you can also use wireless optical CDMA in the terrestrial link. Basically, if you see the previous example, I have shown you the optical fiber network, but you can use a wireless optical CDMA system also. In this scenario, what I have done, I have used one transmitter at building 1, another receiver at the building 2, and the link distance which I assumed was 1 kilometer. Okay, then I considered all the factors which affect the performance, like attenuation due to absorption and scattering by using some mathematical models. Then turbulence, then for turbulence or for fading, we have various fading models. It can be log normal, it can be gamma gamma. Now we have Weibull distribution. So now people are using more distributions. So we used these different distributions based on our what is the basis. We want that distribution or fading PDF distribution which we can say that imitate the actual atmospheric condition in a better manner. So we use that. So I have used log normal and gamma gamma distribution for my research. So after that means in the performance, means first of all I analyze the performance in the optical fiber network, then analyze the performance of the codes in the wireless optical CDMA system. After that, I found that the performance was not good, like probability of error or bit error rate, it was coming out to be in the area of range of 10 to the power minus 2 or 3 when you have 4 users at the transmitter. Okay, so for improving that performance, what I did, I used many performance enhancement techniques like hard limiters. So what is hard limiter? Hard limiter is basically a device which is used at the receiver to decrease the effect of multiple access interference. So if we use optical codes, then in optical codes we have multiple access interference. So what is multiple access interference? Suppose that if you have more than one transmitter or more than one user in the system, and at the receiver you are receiving optical signal from user 1 as well as user 2, but you want to recover the signal or means information from the user 1 only. So the user 2 information or optical signal, it will act like a multiple interference for the user means user 1 receiver. Okay, so the undesired user or transmitter information, it will act like a interference for the intended receiver. Okay, so that is basically multiple access interference. Then hard limiter, what it does, it basically remove the interference above a particular threshold. So these are the devices which are used in the optical communication and for removing the optical multiple access interference. So here I used optical means on off keying modulation technique, but if you will use a ppm, then you may not require this means you can use ppm also. There are many modulation techniques which you can use here. Another performance enhancement technique is your spatial diversity. Like what does it mean? Means we can use multiple receivers or multiple transmitter. It can be CMO, it can be MIMO, it can be MISO. So there are various spatial diversity techniques which can be used to increase the performance of the wireless optical communication system. The third is your error correcting codes. So in case of error correcting codes, what we do, intentionally we add some more bits at the transmitter, and the purpose of this is that you can detect and correct the errors at the receiver. Okay, so we use error correcting codes also. So in my research work, I use some error correcting codes to improve the performance. So the third means fourth is your adaptive power schemes. So why we use adaptive power schemes? Suppose that in your channel or in your in the atmosphere, if there is no fog or no rain or no any other factor like rain, fog, dust particles, then if your power will be less, even then your signal will be able, means we will be able to recover our signal at the receiver or able to detect our signal at the receiver when your power is low also, like less power. Okay, but when there is fog or any rain or any other performance degrading factors, then we need more power at the receiver. So we need a system which can use adaptive power schemes. Okay, so this is also one of the way of enhancing the performance of the wireless optical communication system. Then you have aperture averaging. So what is aperture averaging? In this case, what we do, at the receiver you have a receiver lens or aperture. Okay, so what we do, intentionally we increase the size of the receiver aperture, and due to this, what is happening, the averaging of the fluctuations or optical intensity variations will take place, and as a result the performance of the system improves. So these are the various performance enhancement techniques which can be used, so which I have used during my PhD research work. So if you are interested in working in this area, then there are many. I only touched a few of them, so you can also try. So thank you very much. If you have any questions or anything, then you can ask me. Or you can, I will share my email ID. So this is my mail ID. You can mail me if you have any doubt or if you are interested in this topic. So I would like to say that there are many areas like visible light communication or power line communication where people are working, and these areas very important from the point of 5G communication. So if you are working, or then we should explore these areas also, because they have really very good application in future. So that's it from my side. Thank you very much. So anything you want to ask or anything, then I have no problem. I can.
Thank you so much, sir, for you giving your valuable information. This is the part from the participant sides. If any questions, please ask too.
Please unmute your mic and you can ask the questions. If any participant want to ask the question, please unmute your mic and ask the question.
I think voice is not audible. They can mail me or they can type in the chat box if they want to ask anything.
Yes, sir. Yes. Any questions from our participant side? Okay. Thank you very much, sir, for your enlightening section. Now, may I invite Gautam Kumar Gupta, HOD of ECA department, to propose a vote of thanks.
Okay. So I'm visible and audible, and we
Yes,
can
sir, you are.
Yes,
Yes,
sir. Yes,
sir.
sir.
Okay, na? Okay. Thank you, Dr. Ajay Kumar Yadav, sir, for your enlightening speech. It's my pleasure to have been asked to conduct this valedictory session on this occasion today. I, on behalf of the entire MIG College of Technology, extend a very hearty vote of thanks to the speaker for gracing today's program and sharing with us his findings and opinions today on wireless optical communication. Thank you, Ajay sir. Thank you for your inspiring talk and sharing your knowledge and research on emerging wireless optical communication technology, which is being used in the mobile industry for fast communication. Numerous advantages and the application of WOC, its transmission, reception, and performance parameters that you have discussed today were very informative. I hope this will help the participants to understand the scope of research in this area and will contribute their innovations in this emerging field. Thank you, sir. Thank you, sir. Thank you, Ajay, sir, for your acceptance of our invitation and delivering this very informative session. Thank you, sir. Okay, now let us conclude this FDP. In this 3-day FDP program, we had the very first day starts with the lecture of Professor Sudhir Das Gupta, Professor and Head of the Department EC, IIT Roorkee. He has discussed about the emerging device technology for meeting post-2020 requirements in digital interconnect world, such as the things like FinFET, TFET, and NCFET were discussed on the very first day. On the second day, Dr. Avatar Singh, Chief Researcher cum Assistant Professor, Adama Science and Technology University, Ethiopia, told us about the research opportunities in VLSI. On the day third, Dr. Ajay Yadav sir, Assistant Professor, Bennett University, Greater Noida, shared his views on wireless optical communication. We had participants. We hope participants have taken advantage of this interactive session and by the expert in this field of electronics and communication technology. I think they are getting so much benefits of this 3-day sessions. Now, finally, I would like to thank from the core of my heart to our management and principal, Dr. Y. Sudhir Garu sir, for granting us permission to conduct this FDP. I would like to congratulate the convener, Dr. Santis Madhulika Sarma Madam, for organizing this program and completing this program successfully. Thank you, Madam. Thank you for your complete efforts. Next, I would like to congratulate the entire organizing team, especially Vijay Kant sir, Rajkumar Jaiswal sir, Ananta Lakshmi Madam, Tirupati Rao sir, and Sridevi Madam for successfully and smoothly conducting the whole session. My warm regards to all the participants from all corners of the countries. They have came on this platform and given us time. We hope participants have taken advantage of these interactive sessions and will realize the potential of this emerging field. I am sure that if you take a look at this FDP program, you will agree that this 3-day FDP is very much busy and productive. The positive feedback that we received from the participant sides are very encouraging, and these are encouraging us to organize more such events in the future. So thank you all for being with us in all this 3-day FDP. Hope we will meet in the next future events. Thank you all. Thank you for your participation. And with these few words, I would like to hand over the session to Vijayakant sir. Thank you. Thank you.
Thank you, sir. Thank you so much, sir,
Thank
for
you,
your
sir.
valuable information. So those who are completed the feedback form, you may leave this section. Once again, I'm repeating, those who are completed your feedback form, you may leave
Hello,
this
thank you
section.
so much, sir. Thank you so
Thank you,
much,
sir.
sir.
Thank you.
Thank you.
Thank you.
Sir, I,
Thank you for
received your
joining.
mail and some certificates are also received. Thank you so much, sir.
Thank you. Thank you.
Okay,
Thank
sir.
you.
Okay. Thank you so much. Thank you.
The participants who have been completed the feedback, you can leave. Good afternoon, Vijay sir. Sir, you are not audible.
Sir, very good afternoon.
Raj, you can stop the recording now.